Hey guys, so here's part 2. We're going to be talking about compounding interest. Okay, so this kind of deals with a lot with the when you put money into an account. A lot of times it's going to be into a bank and you're putting into a savings, a checking, some type of account, and you're compounding. So the idea is that you're getting interest off of your interest, because there is a thing called just simple interest, and that means you just have a principal, you have your interest and add it to the principal, and that's it. Here we can take our principal, add it with the interest, and then get interest on top of that value. So this helps because we can gain more money instead of using the simple interest. Okay, so here's our formula we have, and I want to talk about what each of these variables represent. Okay, A is representing our final amount. P is going to be what we call the principal, or the initial amount. R is going to be the rate, as we did before with our exponential decay and growth models. And we need to make sure it's as a decimal, so no longer a percentage. N is going to represent the number of times we compound per that year. So that means you can actually do this multiple times. That means you could compound once a year. You could do it twice a year. You could do it 4 times a year, so that would be like quarterly. If you do it twice, sometimes they might say biannually. You could do monthly, so that means 12 times a year. Weekly, so 52 times a year, or every single day. That would be 365, okay? And then T represents, of course, our time, and that will be in years, okay? Okay, make sure you have this written down, so if you got to pause the video, you can do that. We're going to go ahead and do a couple of problems using this formula. Okay, so it says we deposit $4,000 in an account that pays 2.92% annual interest. So you basically get that 2.92% each year. We're going to find the balance after 5 years if the interest is compounded with a given frequency. So the thing is, your percentage stays 2.92% each year. But if we compound more than once a year, basically that percentage, which of course we change to a decimal, that kind of gets segmented by how many times we are compounding. So like you can think about if we have 2.92% and we compound just twice a year, you would take that divided by 2, of course change your percentage to a decimal, and so that's the percentage you get on the first time you are doing your compound interest, and then the second time as well. So basically the percentage does divvy up by how many times you compound per year, and that's why we want to make sure that we have that annual interest. Okay, so that's just a little bit, some stuff. You don't really have to know that to do all this. I just want to give you a little bit more information about that. And of course, you can look this up to get even more information about compound interest and how it works and all that good stuff. Okay, so we are going to compound quarterly. So think about, what does quarterly mean? How many times would that represent? Well, think about how many quarters are there in a dollar. There's 4, right? We say, I don't know, quarter till 12. Well, we think about that. How many quarters if we think about in 60 minutes? There's 4, because there's 15-minute periods. So whenever we see quarterly, that always means 4. So that means you're compounding 4 times every single year. So that seems like, I think it's about every 3rd month you are compounding. Okay, let's first talk about our principal, the initial amount. We initially put $4,000 into the account. Then our rate, don't forget, we got to change that percentage into a decimal, meaning I need to move the decimal over 2 times to the left. So I have 0.0292. We said the number of times we compound is 4, and then our time that we're compounding is 5 years. Now we basically just plug this into our formula. So I have A equals 4,000 times 1 plus our R divided by 4 to the n times t time, so 4 times 5. Now, I do want to show you how you will plug this into your calculator. And I'm going to do it in the way that, even scientific calculators will plug this in. So we first do 4,000, then plus. Now I need to do parentheses, 1 plus. Now because I have this fraction, I have to do another set of parentheses. Ooh, excuse me, that should not have been 4,000 plus. It should just been parentheses, 1 plus. Parentheses. There we go. Okay, so I'm going to first put my numerator in, divide by 4. Now, after this, I have to do 2 sets of parentheses to close the fraction and to close the 1 plus. Now, I do to the. Now, for those using the scientific calculator, yours is just going to have the caret key. So if you put 4 times 5, make sure you put parentheses around that, okay? So I'm going to go ahead and show you. Now, another thing is you already know what 4 times 5 is, so you can put 20 here. But sometimes the numbers get really large, so you might want to use just the multiplication here. So I do 4 times 5. Now, if you're using a graphic calculator, you don't need to use parentheses. But if you're using a scientific calculator, you have to use parentheses. And then we press enter. And this will be our final amount. So remember, because this is dealing with money, we're going to round to 2 decimal places. So my amount is $4,626.33. And don't forget your dollar sign. Okay. Okay. So now what I would like you to do is go ahead and try part B. So your principal, your rate, and your time stays exactly the same. It's the end value that's going to change. So go ahead and pause the video and try part B. Okay, let's see what you got. So as I said, our principal stays exactly the same. Our rate stays exactly the same. And this is just really showing you to keep everything the same except for how many times we compound. This is showing you, well, what frequency actually works better to get the most amount of money. So daily, well, how many days are there in a year? There's 365. We're not doing leap years, so it's going to be 365. And our time stays the same as well. Okay, plugging this in. Now 4,000, then 1 plus over our 365, and then 365 times 5. Okay. Now, if you haven't already tried it with the calculator, go ahead and pause the video and try to plug this into your calculator just to make sure you know how to do that. Okay, let's see what you got. Now, before I plug this in, if we are compounding more often, do you think our values, the money that we're going to get, is going to be bigger or smaller than when we compounded quarterly? Well, hopefully you said bigger because we are compounding more often. So that means we should get a little bit more money. Maybe not significantly more, but for this amount we will. Okay, so we do 1 plus parentheses, the 0.0292 divided by 365. So if we did that, whoops, and I should have not closed that parentheses there, so I'm going to rewrite this. Okay, now 2 sets of parentheses. There we go. Now this is why I said, to use parentheses, because 365 times 5, I can't do that in my head. So that's why I just write it like that. Okay, so we get $4,628.76. We round up because that third value after the decimal is a 7, so we round up. That's our answer. Okay, make sure you watch part 3. That's where we're going to talk about compounding continuously.